Hello children, how are you all? I hope you all are fine. In this video session of today, I shall discuss the chapter of indices or exponents, which does come in the mathematics syllabus of class 8 or 9. This chapter, is very important because in the higher classes, in deriving the units of different quantities, okay, this chapter is going to come to so much of uses. Okay, so give it sufficient importance in learning, in understanding the concepts of this chapter, indices or exponents, right? So without wasting much time, let us give it a very good start. Yes, my name is Bapindas and you're watching your favorite channel eTuition. Come. The chapter we are going to do today is indices or exponents. Indices or exponents, right? Now let me tell you, in the previous classes we got to learn that if a is a real number, if a is a real number and n is a natural number, n is a natural number. What is a natural number? 1, 2, 3, 4 or things like that. Okay, n is a natural number. Then a to the power n, what does that mean? A multiplied by a multiplied by a in this way up to n times, right? Up to n times. Okay, as an example I may tell you is 2 to the power 3. What does that mean? 2 into 2 into 2. 2 is multiplied with itself up to 3 times, right? Then 2 to the power 5. What does that mean? 2 into 2 into 2 up to what? 5 times. Then what is 2 to the power n? 2 is multiplied with 2 up to n times, right? That is what I'm writing here. Is any such number like 2, 3, any real number. Okay, so what is a here? A here is called the base actually. And what is this n? This n is called the index or exponent. Index or exponent. Okay, the thing which is coming in the superscript is being called as index or exponent, and that is what this chapter is all about. Indices or exponents. Okay, the plural form of index is indices. Plural form of the word index is actually indices. Don't make a mess of index and indices, because index is same as indices. Indices is only the plural form, right? And index is a singular form. Exponent has its plural form simply as exponents, right? But index has its plural form as indices. All right, so now the superscript, the natural number which comes in the superscript of a real number in an expression like a to the power n is called the index or exponent, right? And a to the power n, this form is actually called the exponential form. A to the power n, a form like this is called the exponential form. Exponential form, right? Now I will tell you a few basic rules or laws of exponents, according to which we shall deal with the sums of this chapter. Okay, laws of exponents. The laws of exponents of real numbers. Okay, for complex numbers or imaginary numbers, the rules may little bit vary, which we will see afterwards in the higher class, in class 11. But for the time being, know the laws of exponents for real numbers. Okay, so what are the laws? I'm writing one by one, okay, and trying to make you understand. After that we shall deal with some typical problems, sums of this chapter, right? So be attentive, very attentive. First law that we are getting is a to the power m multiplied by a to the power n equal to a to the power m plus n. Okay, see, the bases are same, so in case of multiplication the indices are getting added up together. All right, then a to the power m divided by a to the power n is equal to a to the power m minus n. The bases are same, so in case of division the indices are getting subtracted. The index or the base in denominator is getting subtracted from the index or the base in numerator, right? A to the power m minus n. Okay, an example I may give you is 2 to the power 3 by 2 to the power 2 is equal to 2 to the power 3 minus 2, or 2 to the power 1 is simply 2. Is it clear? And for this one, for the first one, I may tell you that 5 to the power 2 multiplied by 5 to the power 3 is equal to 5 to the power 2 plus 3, or 5 to the power 5. Okay, what is 5 to the power 5? 5 multiplied with 5 up to 5 times. Okay, so some value is going to come over here. So in this way, the third law as is there is a to the power m whole to the power n is equal to a to the power mn, right? So these m and n are getting multiplied together and is coming as the index or the exponent over the base a. Okay, after that, see, in number 4 it's coming a to the power m multiplied by b to the power m. See, the indices on a and b are same. Okay, so in that case we may write a into b whole to the power m. Is it clear? Okay, next is number 5. A by b whole to the power m is equal to a to the power m upon b to the power m. Okay, now number 6. A to the power minus n is equal to 1 by a to the power plus n. This is very important. Okay, in physics, in the SI units of some quantities of physics, okay, you have to understand this. A to the power minus n equal to 1 by a to the power plus n. Okay, an example of this I may give you is 2 to the power minus 2. What does that mean? That means 1 by 2 to the power plus 2 is equal to 1 by 2 to the power plus 2 means 2 multiplied by 2, right? 1 by 4, as simple as that. Okay, one such example from physics I may give you, that in deriving this unit of density, what is density? Density is equal to mass by volume, right? So what should be the unit of mass? SI unit kg. What should be the unit of volume? Is meter cube, right? 1 by meter cubes. What does that mean? Kg meter to the power minus 3, right? Kg into meter to the power minus 3. Kg though is already there in numerator. Kg is like as it was in the previous step, but 1 by meter cube has changed to meter to the power minus 3, right? So just as this one, 1 by 2 square has changed to 2 to the power minus 2. 1 by 2 cube, if it would be, then that would have changed to 2 to the power minus 3, right? So 1 by meter cube can simply be written as meter to the power minus 3. Is it clear? After that, see, in number 7 it is coming like, if a to the power n is equal to b to the power n and n is not equal to 0, then we can write that a is equal to b, equality of the two bases. Okay, if these two things are equal, in spite of having the different bases, the powers are equal, so we can declare that a is equal to b. The condition is n must be not equal to 0. Okay, if n is equal to 0, then both sides would have simply been equal to 1. Okay, whatever be the values of a and b, not necessarily equal, because anything whole to the power 0 is equal to 1. Have you known this, that a to the power 0 equal to 1? This is very important, keep it in mind. Okay, and I'm showing you how it is coming. What is a to the power 0? A to the power 0, a to the power 0 is actually, am I able to write it like a to the power 2 minus 2 or 3 minus 3 or 4 minus 4, simply in this way. What is a to the power 2 minus 2? Have a look at what the rule number 2 says. A to the power m by a to the power n equal to a to the power m minus n, right? So in place of a to the power m minus n, am I able to write a to the power m by a to the power n? Of course I can. So a to the power 2 minus 2 is what we can write as a to the power 2 by a to the power 2, a square by a square. Okay, so they have cancelled each other, so what we are left with is 1. This way, a to the power 0 can also be written as a to the power 5 minus 5, 6 minus 6, a to the power 100 minus 100, whatever it is. Am I clear? So anything whole to the power 0 is equal to 1. Keep this in mind. Okay, put this inside your brain anyhow. Okay, and keep it confined there. anything whole to the power 0 is equal to 1. Is it clear? That is why, okay, n must not be equal to 0. You know, if n is equal to 0, then a to the power 0 equal to 1 and b to the power 0 is also equal to 1. Okay, so both sides are getting automatically equal to 1 if n is equal to 0. Not a and b have to be same in that case, right? That is why if n is not equal to 0 and in spite of that a to the power n is equal to what, b to the power n, then we may say that a is equal to 0. Okay, or else a may simply be unequal to b and a to the power 0 equal to b to the power 0, right? Because both are equal to 1. That is why the restriction n is not equal to 0 here. After that, in number 8, there is another thing, a to the power m is equal to a to the power n. Okay, and if a is not equal to 1, then we may write that m is equal to n. Equality of indices, because the bases are same, you know, bases are same here and base must not be equal to 1, because 1 to the power anything is 1 now. You know, 1 to the power anything is equal to 1. Keep this thing in mind. That is why if the base a would have been 1 here, then 1 to the power 3 would simply be equal to 1 to the power 4. Okay, right? Because 1 into 1 into 1 is 1 to the power 3 is 1 only. 1 to the power 4, 1 into 1 into 1 into 1 is 1 only. Both are equal easily, but am I able to write in that case 3 is equal to 4? Never. 3 can never be equal to 4. That is why there is a restriction that a must not be equal to 1, because as soon as the base becomes equal to 1, then the base to the power anything and base to the power everything is same actually, because you know 1 to the power anything is equal to 1, not a value other than 1 you will get. Okay, so that is why the restriction is here. So that's all about the laws of indices or exponents, based on which we need to proceed in dealing with the sums of this chapter. Okay, so let's come to solve a few sums, typical sums, which I'm considering as comparatively harder ones, okay, or typical ones, and having the concepts of solving those sums. Okay, so you hopefully will have the skill of dealing with the other sums of this chapter. Okay, I'm solving from the book of M.L. Aggarwal, from the book of mathematics of class 9 by M.L. Aggarwal. All right, so let's enter into the exercise of chapter 8, which is indices. Okay, I'm showing you some typical sums, how to solve. Exercise 8. Okay, the first sum I want to do is question number 1. Simplify. Simplify what? 81 by 16 whole to the power minus 3 by 4. Okay, what is 81? If you do the prime factorization of 81, so you can see that okay, what is 81? It is 3 to the power 4. What is 16? If you do prime factorization of 16, you can see that 16 is nothing but 2 to the power 4 whole to the power minus 3 by 4 equal to 3 by 2 whole to the power 4, right? That is one law which we learnt. Minus 3 by 4 equal to 3 by 2 whole to the power 4 multiplied by minus 3 by 4. Okay, 4 cancels out, and 3 by 2 whole to the power minus 3. What is 3 by 2 whole to the power minus 3? We can write 1 by 3 by 2 whole to the power plus 3, because I told you that a to the power minus m is equal to 1 by a to the power plus m, right? Okay, so that is what we are making use of in this step. Is it clear? Then 1 by, what is 3 cube? 3 cube is nothing but 27. What is 2 cube? 2 cube is nothing but 8. So what we are left with as the final answer is 8 by 27. Yes, that should be our answer only. After that, okay, I want to do question number 2. What is that? Same thing, simplify. simplify what have we been asked to simplify? A to the power 1 plus b to the power 1 by ab whole to the power minus 1. Okay, a to the power 1 means 1 by a, b to the power 1 means 1 by b, ab to the power minus 1 means 1 by ab to the power plus 1, right? 1 by a plus 1 by, we take ab as LCM, so here we are left with a b plus a, denominator 1 by ab, right? So b plus a by ab multiplied by ab by 1, because you know the fraction in denominator has been inverted because that's getting multiplied. Okay, ab have cancelled out, so all we are left with at the end is b plus a, and that is our answer of simplification. Are things getting clear? Then see, similar kind of such sums are given afterwards. Okay, so which I hope you'll get to solve on your own. Question number 4's one is the one I want to solve now. 3a by b to the power minus 1 plus 2b by a to the power minus 1. b to the power minus 1, what does that mean? 1 by b to the power plus 1, right? 2b by a to the power minus 1, what does that mean? 1 by a to the power plus 1. Okay, 3a multiplied by b, 3ab has come here. 2b multiplied by a, 2ab has come here. So all that is coming out as the answer is 5ab. Okay, then after that question number 7's 2. Okay, this one I want to show you. You know, some typical sums from the entire exercise I have marked, which I am showing you now. Okay, so if you understand all the steps of solution of these typical sums, okay, I hope the other sums you will end up doing on yourselves. Okay, so see the one I'm doing now, 7's 2. What does it say? The same instruction, simplification. 5 into 25 whole to the power n plus 1 minus 25 into 5 to the power 2n, okay, divided by 5 into 5 to the power 2n plus 3 minus 25 whole to the power n plus 1. Let us see what the answer comes. 5 to the power 1 into 5 square whole to the power n plus 1 minus 5 square into 5 to the power 2n whole divided by 5 to the power 1 into 5 to the power 2n plus 3 minus 5 square whole to the power n plus 1. Okay, the page is going to be finished, so we need to move to the next page. 5 to the power 1 into 5 to the power 2n plus 2. Is it clear? Because you know a to the power m whole to the power n equal to a to the power mn, right? That is why we are multiplying these two with this n plus 1. Is it clear? That is why 2n plus 2 is coming over this 5. After that 5 square multiplied by 5 to the power 2n, okay, well divided by to the power 1 into 5 to the power 2n plus 3 minus 5 to the power 2n plus 2. Okay, after that we need to move to the next page. I'm doing one more step in this page. 5 to the power 1 plus 2n plus 2. I'm adding up the indices, right? That's what the rule for multiplication is. Minus 5 to the power 2 plus 2n, is it clear? Divided by 5 to the power 1 plus 2n plus 3 minus 5 to the power 2n plus 2. Okay, now I'm moving to the next page here. I am moving to the next page here. Okay, moving to the next page here. Is equal to 5 to the power 2n plus 3 minus 5 to the power 2n plus 2 divided by 5 to the power 2n plus 4 minus 5 to the power 2n plus 2. Now see, we need to cancel out from numerator and denominator. In order to cancel out, we need to take out some common. What can we take out as common? The lowest power and the common power between the numerator and denominator. Have a look closely at the powers of both the 5's in numerator, 2n plus 3 and 2n plus 2. Which is smaller? 2n plus 2, of course, right? So 5 to the power 2n plus 2 can be taken out as common. What are we left with? 5 to the power of 1. Why? See, 5 to the power 2n plus 2 into 5 to the power of 1. What does that give? 5 to the power 2n plus 2 plus 1 means 5 to the power 2n plus 3, right? So from 2n plus 3, if you subtract 2n plus 2, what is left? 1. That is why inside bracket 5 to the power 1 is coming, minus what will come from the second term if 5 to the power 2n plus 2 is taken out. Simply 1 will be remaining, because 5 to the power 2n plus 2, entire thing has been taken out of the bracket, right? So what is left inside the bracket is 1, nothing else. And below in denominator, see 5 to the power 2n plus 4, okay, and here 5 to the power 2n plus 2. If you take 5 to the power 2n plus 2 common out, then 5 square is remaining here from the first term in denominator. From the second term, all that is remaining is 1. Okay, the same thing is here. I'm not explaining. 5 to the power 2n plus 2 into 5 square is giving you 5 to the power 2n plus 4, because both the indices getting added up to give you 2n plus 4, right? This plus this, because multiplication, right? Get to know and get to understand the rules for indices or exponents, the laws for indices or exponents properly. Laws, are your arms, okay. Once you have the arms in your hand, okay, you will have the victory in the battlefield. That is guaranteed, that is certain. Okay, so the rules for exponents or indices are your arms in this chapter. Without them, you cannot proceed a single step further. All right, so see here, as soon as you have taken some common factors in numerator and denominator, you may feel free to cancel them out. Okay, 5 to the power 2n plus 2 and 5 to the power 2n plus 2 getting cancelled out. Numerator, all you are left with is 5 minus 1, that is 4. In denominator, all you are left with 25 minus 1. Okay, that is 4 by 24. What does that mean? 1 by 6. Yes, that is your answer, 1 by 6. Okay, nice one it was. After that, I want to do question number 10's one. Question number 10's one. Same instruction, simplification. 3 square whole to the power 0 plus 3 to the power what, minus 4 into 3 to the power plus 6 plus 1 by 3 whole to the power minus 2. Okay, well, I have told you already is that anything whole to the power 0 is 1, isn't it? 3 square means, what does that mean? That is 9. 9 to the power 0 means 1 only. Without any hesitation, without any second thought, just write 1 as soon as there is anything whole to the power 0. Anything means anything, right? Any fraction, any positive number, any negative number, whatever it is, anything whole to the power 0 means 1. Okay, so let it be equal to 1 anywhere you come across such thing. Plus 3 to the power minus 4 into 3 to the power plus 6. These are getting multiplied, so indices are supposed to be added up. 3 to the power minus 4 plus 6, we can write it here, plus 1 by 3 whole to the power minus 2. Okay, 1 by 3 whole to the power minus 2. What does that mean? 1 by 3 whole to the power plus 2, isn't it? Because we have known already that a to the power minus m is equal to 1 by a to the power plus m, isn't it? As per this rule, we may write it in this way. 1 by 3 whole to the power minus 2 means 1 by 3 whole to the power plus 2, isn't it? So 1 plus 3 to the power, how much has it come? Minus 4 plus 6 means plus 2, plus 1 by 9, isn't it? 1 by 3 whole square, what does that fetch you? 1 by 9. 1 by 3 multiplied by 1 by 3, 1 by 9. So here 1 plus 3 square means 9, plus 1 by 9 will give you 9 itself. Answer is 19. Okay, 9 plus 9, 18, plus 1 is 19. Is it clear? I think it is getting clear to all of you. After that, the one I want to do is question number 17(2). Question number 17(2) is x to the power 1 by 3 minus x to the power minus 1 by 3. Okay, x to the power 2 by 3 plus 1 plus x to the power minus 2 by 3, right? Now see, this is actually in the format of a popular formula of algebra. Formula is a cube minus b cube. How is it? I'm showing you. Have patience and see. X to the power 1 by 3 minus x to the power minus 1 by 3. After that, see closely. X to the power 2 by 3. Am I able to write it in this way? X to the power 1 by 3 whole to the power 2. Of course I can, because we did one rule. Can you remember? X to the power m whole to the power n equal to x to the power mn. So in reverse way, am I able to write x to the power mn is equal to x to the power m whole to the power n? Of course I can. So x to the power 2, x to the power 1 by 3 into x to the power into 2. Am I able to write it like this? X to the power 1 by 3 whole to the power 2. Of course I can. That is what I've done here. See, x to the power 2 by 3 means this one, okay, has been written in this way. Okay, after that, see, what is this 1? 1 is actually x to the power 1 by 3 multiplied by x to the power minus 1 by 3, isn't it? Because if you multiply these terms, then powers will get added up. Powers means indices or exponents will get added up. Plus 1 by 3 minus 1 by 3, there is 0, x to the power 0. What does that mean? 1. Told you already repeatedly that anything whole to the power 0 is 1, right? So this term is nothing but 1 Rasagulla. This term is nothing but Rasagulla 0. This term is nothing but, so this term is nothing but 1. This term is nothing but this 1. Okay, have you understood? After that, see, x to the power minus 2 by 3. Am I able to write it in this way? X to the power minus 1 by 3 whole square. Okay, that is giving you minus 2 by 3 only, because minus 1 by 3 multiplied by this 2 giving you minus 2 by 3. So what formula is this? A minus b into a square plus ab plus b square. Yes, that is the formula of a cube minus b cube. Okay, so a cube minus b cube. Because you know, this thing is actually a minus b into a square plus ab plus b square. What is a here? A here is x to the power 1 by 3 and b here is x to the power minus 1 by 3. Yes, if these things are a and b, then this expression is nothing but a minus b multiplied by a square plus ab plus b square. So that is necessarily the formula for a cube minus b cube. A cube minus b cube. Okay, that is why I've written it like this: x to the power 1 by 3 whole cube minus x to the power minus 1 by 3 whole cube. So what you are getting in the end is x to the power 1 by 3 into 3 minus x to the power minus 1 by 3 into 3. 3 cancels out, 3 cancel out, x to the power 1 minus x to the power minus 1. So you may write it as x minus 1 by x. Okay, that is simply the answer. Okay, so this is actually the first part of the video, and quite a few more varieties of typical sums are still left. Because this video is getting elongated and long, I'm feeling like to end the video over here, but a second part of this video is going to come very soon. Make sure to watch the second part of the video as well in order to know how to solve different types typical sums of this chapter of indices or exponents. All right, so that's all for this session. All the very best. Keep on studying. Bye bye. Take care.